Today, we're diving into a really cool paper called The Use of Engineering Laboratories for Teaching Physics. It's all about a challenge that, honestly, a lot of us have probably thought about.
So here's the big question, right? How do you get these abstract laws of physics to really click for students who are, hardwired to build, to design, and to create things in the real world?
Well, a team of researchers at the Maua Institute of Technology in Brazil has been using a project-based learning approach to tackle this. And, when you first look at the results, you'd think they've totally cracked it. Everything looks great. I mean, just check this out. Look at the massive jump between the blue bars, that's before the project, and the green ones, after. Before, students were kind of so-so on reading scientific papers. But afterwards, boom, we're talking 98% feel capable. That's a huge, undeniable win.
And it doesn't stop there. Did a project help them understand the theory? Yup. Develop hands-on experimental skills? Absolutely. More than 86% of students gave it a thumbs up across the board. So they're clearly connecting the textbook stuff to the real world.
And this slide really seals the deal. You ask them about creating physical models, testing them, basically the heart of engineering. And again, almost every single student feels confident they can do it. So you think, case closed, problem solved. But not quite. This is where things get really interesting. See, the researchers had a hunch that something was still missing. They decided to ask one more question, this one about context. And the answer they got, well, it pointed to a pretty significant gap in their approach. And this is the core of their discovery. The students were learning the physics, no doubt, but were they seeing how that physics applied to their own specific field of engineering? Turns out, for a lot of them, the answer was no. They found what they call the context gap. And this chart just lays it all out, crystal clear. Look at B. When you ask, did this project help you see physics and engineering in general, 68% say yes. Okay, not bad. But when you ask, did it help you see physics in your specific field of engineering, that number just nosedives to 41%. That is a huge disconnect. And this quote from a computer engineering student just nails it. They said one of the hardest parts was figuring out how to actually use the experiment in real-world engineering. The connection just wasn't there for them. So what do you do with a discovery like that? Well, instead of getting discouraged, the researchers came up with a new proposal. And honestly, it's brilliant. The whole idea is laid out in their work, which they're going to be presenting at the 2025 ASEE Annual Conference and Exposition. The solution is just so wonderfully simple. Stop making engineering students come to the physics lab and instead bring the physics lessons into the engineering labs. I mean, the logic is just perfect, isn't it? If students are having trouble seeing the connection, just put them in a room where that connection is staring them right in the face. It's impossible to miss. So, what does this actually look like? The team has come up with 4 initial experiments to pilot this idea. Now, it's really important to remember, these are just proposals right now. The plan is to start rolling them out in 2025. So, for example, imagine you're in the automotive lab. You'd use a car lift to figure out the center of gravity of a mini car. That's a direct lesson in static equilibrium. Or you'd go to the manufacturing lab and study kinematics using the actual robotic arms they'll be working with in their careers. Or how about this? In the materials lab, you're using a real-deal tensile machine to test elasticity. Way cooler than just a spring. And in the machining lab, a simple drill press suddenly becomes a hands-on lesson in torque and angular velocity. Every single experiment is grounded in the real tools of their future trade. So it really all comes down to this one big idea, contextualization. It's about bridging that gap. When you place the physics lesson right inside the engineering world, the theory isn't some abstract thing anymore. It becomes a tool, something real, something useful. And that is what really fires up motivation and makes the learning stick. And it leaves us with this really powerful question to think about, not just for engineering, but for all of education. Why do we separate the theory from the practice so often? What if, for the next generation, the classroom was the workshop?